Hello friends, welcome back to New LJ Commerce College MOOC. I am Dr. Stuti Dholakia. I am working as the Associate Professor at New LJ Commerce College. Today we are going to see Semester 5's Statistics topic, Unit 4, that is Lot Control or Acceptance Sampling. Today we are going to learn the examples of first method, that is examples based on hypergeometric distribution. First of all, let's see single sampling plan. The notation for single sampling plan is SSP, capital N, that is lot size, small n, that is sample size, and C, that is allowable number of defects. Now here we have to use the distributions to calculate probability of accepting the lot. So to identify when which distribution should be used, the first step is determine or see the value of capital N. If capital N is less or equal to 200, if it is a smaller number than 200 or equal to 200, then we have to use hypergeometric distribution. If capital N is a larger number than 200, then we have to use Poisson distribution, and if in the question it is asked to use binomial distribution, then only binomial distribution will be used. Now let's see today the example of hypergeometric distribution. Now the probability of accepting the lot, the formula is sigma d is from 0 to c, capital NP dash CD, capital N minus NP dash C n minus d upon capital N C n. Now let's see the example. For single sampling plan SSP 100, 10, 0, if lot proportion defective, that is P dash, is 0.03, the question is then find the probability of accepting the lot. Now here capital N is 100, so we have to use hypergeometric distribution. So the formula for PA will be summation d is from 0 to c, np dash capital NP dash CD, capital N minus capital NP dash C n minus d upon capital N C n. Here small n is 10, C is 0, that means allowable number of defects are 0, that is d value must be equal to 0. Now if we substitute all these values and P dash value that is given in the question as 0.03, so we will get capital N into P dash, that will be equal to 3. So PA value equal to 3C0 into 97C10 upon 100C10. Now anything C0 is always 1. So 3C0, that is equal to 1. So the PA value will be 1 into 97C10 upon 100C10. Now let's use the formula of NCR, that is equal to n factorial upon r factorial into n minus r factorial. So PA value will be equal to 97 factorial upon 10 factorial into 87 factorial whole divided by 100 factorial upon 10 factorial into 90 factorial. Now denominator's denominator will come out in the numerator. So it will be 97 factorial upon 10 factorial into 87 factorial into 10 factorial into 90 factorial upon 100 factorial. So if you check out this result, 10 factorial values will be cancelled from numerator and denominator. Still if we go further, see the numbers 97 factorial and 100 factorial. So now 100 factorial can be written in terms of 97 factorial using 100 into 99 into 98 into 97 factorial. Similarly, 90 factorial can be written using 90 into 89 into 88 into 87 factorial. So now we are substituting the values of 100 factorial and 90 factorial. So the next step will be 97 factorial upon 87 factorial into the substitution result of 90 factorial, that is 90 into 89 into 88 into 87 factorial divided by 100 into 99 into 98 into 97 factorial. So now 97 factorial will be cancelled. At the same time 87 factorial will also be cancelled. So the final PA value will be just 90 into 89 into 88 upon 100 into 99 into 98. So the final answer will come out to be 0.7265. It seems really a difficult method, isn't it? So now let's check out the shortcut method, how we can directly come from the first step to the last step. Okay, so let's just summarize now this shortcut method. But please remember this thing, this shortcut method is only for C is equal to 0. If we change the C value, then there will be once again some changes in the calculation step. Now here, first of all, directly we have to go for PA result. What is that result? 3C0 into 97C10 upon 100C10. This we want to simplify it further. Okay, so let's see. Now first calculate capital N into P dash. Here capital N P dash is equal to 3. So there will be the multiplication of 3 terms in the numerator as well as the denominator in the final answer. Now find the value of capital N and small n. Substitute it in the formula of capital N minus small n, and here since capital N is 100 and small n is 10, so capital N minus small n, that will be 90. Now our numerator will start from this number capital N minus small n, and our denominator will start from the number capital N, and then it will be reduced, both these terms will be reduced by 3 terms, 3 consecutive reduction terms. So now this PA value will be, from numerator we have to start with 90, reduce 3 terms. From denominator we have to start from number 100, once again reduce the same number of terms, that means 3 terms. So final answer for PA will be 90 into 89 into 88 divided by 100 into 99 into 98. So it will come out to be the same number, 0.7265. I hope this method is quite easier to you. Now let's see the next example based on this kind of shortcut calculation. The next question is for SSP single sampling plan 150, 10, 0. Now if lot proportion defectives are 2% and 4%, then find the probabilities of accepting the lot. Since you can check out this number, C is 0, so we can use our shortcut method. Okay, let's go further. Here capital N is 150, so we can use hypergeometric distribution. So PA, the general formula for hypergeometric is summation D is from 0 to C, capital N P dash C D, capital N minus capital N P dash C small n minus d upon capital N C n. Here small n is 10, C is 0, so D is equal to 0. Now P dash, first number is given as 2%, that is 2 divided by 100, that is 0.02. So we need to calculate just one step now, that is capital N into P dash, that will be 150 into 0.02, that is equal to 3. Here capital N minus small n is 140. That means in numerator we have to start from number 140. reduce just 3 terms. In denominator, we have to start from capital N, that is 150. Once again reduce 3 terms. So now PA value will be, directly we can calculate it as 140 into 139 into 138 divided by 150 into 149 into 148. So final answer value will be 0.8119. Now similarly we can calculate for the second P dash value. Let's go for it. Now P dash is 4%, that is 4 upon 100, that is 0.04. Capital N P dash, now it will be 150 into 0.04. That is, now we have to go for 6 terms reduction. Same number, capital N minus small n, that will be 140. Now PA general result can be written like this one. Say D is from 0 to 0. Since C is 0, 6CD 144 C 10 minus D, and then divided by 150 C 10. Now here the terms will be 140 reduce at 6 terms. So it will be 140 into 139 into 138 into 137 into 136 into 135. Now divided by 150, once again reduce the same number of terms. So it will be 150 into 149 into 148 into 147 into 146 into 145. Now this number will be a bigger number, larger one. So can we reduce it further? So let's just recall that earlier concept. Earlier result for P dash 0.02 was PA, just 3 terms was there and the final answer was 0.8119. If we check out the same result for P dash 6 terms, then the earlier 3 terms we have already calculated the number. So I am just substituting the earlier 3 terms multiplication and division number to be equal to 0.8119. So now it will be 0.8119 into, let's just multiply and divide by the remaining 3 terms. So it will be into 137 into 136 into 135 divided by 147 into 146 into 145. So we will get the final answer, that is 0.6562. Check out one more thing. If P dash increases, proportion defective increases, then definitely the probability of accepting the lot should be decreased in value. Now I hope this shortcut method is quite easier to you, all of you, and now you can solve the examples using this concept. Thank you so much.